Alright, here we have lab 1. My name is Josh Lorenzo. I apologize in advance because for some reason, excuse me, every time I speak, um, my voice gets raspy and it's difficult to talk, so if I cough, I apologize. Here we have our ingredients or components. We have the switch, the LED resistor. We have our switches here, LED, and the resistor. We also have our USB cable, which is connected to our power source. And we have our jump wires here connected along the breadboard. So the object of this project was to get some of your tools, make a simple circuit with some switches, an LED, and a resistor. So in a circuit, as you can see here from the book on page 21, says that electricity flows from a higher energy, which is indicated by this red cable, and the higher energy is also referred to as power, and it flows to low potential energy, also known as ground, which is indicated by this black wire here. Along the reading, they talk about current, which is measured in amps or amperes, with the symbol A or I. Excuse me. Also talks about voltage, which is measured in V, and resistance, which is measured in ohms with the omega symbol. Towards the end of the reading, we find out that all these relate to each other, and it is known as the Ohm's law. Here we have a nice little diagram which shows how you can calculate each of these values. Just by using that little diagram, you cover up the specific term you'd like to figure out, and then you just plug in your values and you solve it. With our project today, we have 5 volts running through the red wire, and we have the 220 ohm resistor, and we're left with the current, which we had to figure out. So to figure out I, you divide V, V and R. V is 5, R is 220, and you get a total of 23 milliamps. Simple math there. So that's pretty much that. In this project, we created a series circuit. That was the diagram for that. Here's the schematic. And pretty much to explain series, in a series circuit, both of the switches had to be depressed right here, because in a series circuit, the current flows through both switches. So in order to close a circuit, you have to press both buttons. So you press this button and this button at the same time, and it closes the circuit here, providing electricity to flow to the LED. The setup that I have here, which for some reason, I don't know why the top switch doesn't work, but the bottom does. I switched out the jump wire before and flipped the switch around, and it would work sometimes, but for some reason it isn't working out. But the theory of a parallel circuit, that's the diagram. Here's a schematic. In a parallel circuit, when the electricity flows through here, since the current is split into two, you can either press one button to close a circuit and provide electricity to flow, or you can press the other, and the electricity will flow through that closed circuit to the LED, providing energy. Which, like I said, I'm not sure why it's not working now with the top switch. Tried switching the switches around, switching jump wires, but right now the only one that works is the bottom one. That's pretty much it for the project. Like I said, we talked about current, voltage, resistance. We had our 220 resistance ohm, our 5 volts, and I'll show you the diagram again that we are presented with to help figure out the relationship and the values for missing variables, either current, voltage, or resistance. And there's the example that we used in the project.